Welcome to the last long session of the afternoon, Thursday, June 10, UGM 2021 for iRODS. This is Jason Coposky from the iRODS Consortium. He's going to talk about the new iRODS client, I guess, C++ REST API, to present iRODS in a more developer-friendly way. Go for it.
All right, thank you. So the motivation here was just to have something that was fast, lightweight, and easy to deploy right alongside of iRODS. And the idea here is that we're going to leverage all of those nice libraries that we have written in order to refactor iRODS in a way on the client side that is going to allow us to present this over REST in order to develop, other interfaces on top of iRODS, as well as to provide straightforward HTTP access to, all of the things that iRODS provides. So this is based on the C++ API as well as the Pistache development library. And I had originally started, working with the, the Open API standard in YAML and whatnot, and tried generating, the bindings with Pistache and using all of that, fill machinery, and pretty much boiled it down to just using the minimum amount of Pistache necessary in order to, build this thing out. So it acts as a proxied mid-tier application layer. So each C++ REST endpoint is effectively a client to iRODS using one or more threads that are defined by the deployment. And ultimately, this is going to use a JSON web token or a JWT for authentication and authorization. Takeaway here is it provides a single executable per endpoint, which gives you the ability to containerize each one of these things if you want and put those behind a proxy, or you can just simply install it on one of your iRODS servers and then stand it up and get the configuration put together, and you are good to go. Speaking of the configuration, each endpoint has its own configuration in a JSON file in etc iRODS. And so that is going to be etc iRODS client REST cpp.json, which is provided as a template followed by the packaging. And we also provide an Nginx template in order to provide a reverse proxy through port 80 to all of the different endpoints for each one of this REST API. And that is going to be the iRODS client REST reverse proxy.conf. And this is going to go into etc Nginx sites available. And then you can link that into sites enabled, bounce Nginx, and you should be basically up and running. So if we take a look at that, you can see that each one of the endpoints has its own section in this JSON object, and which defines its own port, the number of threads, and then there are some various other configuration that you're going to find in here per endpoint. So the get configuration endpoint requires an API key. We have an idle timeout in seconds for all of these things, as well as the ports. And as we build this out, we're just going to have additional endpoints in here for each of these configurations. For Nginx, that's a bit more complicated. We've had to add this options section here for the zone management tool, which we'll hear about later, as well as the various headers and whatnot that we have needed. And one thing to keep in mind is that there are a couple endpoints that actually take advantage of the put and get methods in order to fan those out through a single URI to the various endpoints. And so configuration is one of those where we proxy out to two different ports for put versus get, as well as the stream option down here. So there's not exactly a one-to-one mapping between the reverse proxy and the number of endpoints. To get everything started, you have to hit the Authentication API, and this is going to generate a JSON web token, which is going to be encrypted on the server side and then passed back to the client. And that is currently using the zone key. So if you're not going to be able to hit another endpoint, well, actually that just complicates things. But anyhow, so this is going to include your identity, your authentication information, your authorization information, and anything else that we might add into the future role-based information. If we're going to work with OIDC in the future or whatnot, would be something along the same lines. So once you hit the auth endpoint, it's going to generate the JOT, And then you're going to send that JWT as the authorization header for any other endpoint that you would like to invoke. So that's very straightforward with curl down here. Just use a -h, authorization, colon, and then the value of your token, which is going to be a very long string. The first endpoint that we're going to look at beyond auth is access. So the access endpoint is going to generate an iRODS ticket here, which is going to be passed as an XAPI key into a subsequent request. So if you invoke the access with a specific path to a data object, it's going to return a ticket for that data object, assuming that you are allowed to have a ticket for that data object, and then give you a URL to hit in order to access that data. And as you can see here, it's going to hit the stream endpoint in order to provide access to that particular data object. The heavily leveraged by the zone management tool is the admin interface. Now, I have not done any work at this point in order to make this more URL friendly or REST friendly, if you will. This is effectively a one-to-one mapping between the curl call and the RS General Admin API on the other end of that particular pipe. You're going to have your token down here, and then from here, you're going to hit the admin endpoint, and then it starts out with an action. So this is going to be add, modify, remove a noun in the system, a target, which is going to be a user, zone, resource, or one of these other nouns or other operations within the system. And things get more generic as we get down to ARG2, ARG3 through ARG7. So typically for ARG2, this would be a username, a resource name, or some other identification of a thing within the system based on your target. And then any other possible parameters we're going to need here. So this is an example of using the admin endpoint in order to add a resource, which is named UFS0, whose type is Unix file system, and whose vault path is temp iRODS UFS0. And then effectively we have to, just pass out blank ARG5, and ARG6 is going to be the zone name. So this will basically, assuming that you have admin access, create a new resource within the system. The authentication endpoint itself will only supports right now either basic or native. Native is effectively using the generic iRODS authentication, but we're also using the term basic in order to make this more appropriate for a REST interface. This is going to be a post. They're going to take no parameters because everything is passed as the authorization header here, where we base64 encoded a username : password, which is a standard, if you will, as a payload for that header. And then we just hit the auth endpoint. So the server will base64 decode that, parse that out, and effectively just try to auth that user with that password as if you were just simply using init. And as I said earlier, that's going to return a JSON web token, which contains everything necessary to interact with the other endpoints. And that is going to be encrypted on the server side. The configuration endpoint will give us the ability to actually get and manipulate the server configuration and all of those JSON files in etc iRODS. This will also be quite useful for the zone management tool, where we'll have a single pane of glass that will give us the ability to manipulate all of the servers within your zone. So if we use a get method, basically we're going to get all of the information back from iRODS and etc iRODS. This does not take the authorization token because you need to have, special access in order to get, that particular bit of information, if you will, and that's why it is configured directly in the JSON configuration for this API. So, as I should say, as a 4.3 plus, the iRODS server itself can use this in order to fetch its configuration. So you can stand up your own centralized service in order to provide configuration to all of the servers within your fleet. And that might have some interesting uses later. So for the get method, we're going to return a JSON object, which has a key with the file name of any file that ends in .json on etc iRODS on the server that is hosting this particular REST endpoint. And then, well, of course, they can contain or include any of the innards of any of those. Now, if you do a put, this is going to assume that it's going to take a single parameter of a URL encoded JSON string of the format array, where we have an object with a file name, and then a key with the contents of that particular file name. And so you can take a look at this example, but it's going to be unintelligible. But effectively, you're just going to stuff the contents of that particular string into this endpoint, and then it will effectively just repave or create new JSON files on any server, anywhere in the area. And sorry, and it's the iRODS. Now, getting back to more iRODS related things, we have a list endpoint, which is going to take a path. So the path is a URL encoded logical path, which is to be listed. You can request additional information with this listing. So you could stat any of the objects within that. You can ask for the permissions. You can ask for associated metadata. You can offset in order to implement pagination, or you can limit the number of records you like per desired page. Now, this is a more interesting result, as in each one of these things is returned as a subcollection with a particular type. We have a data object type here. And then down here, we have a list of supporting links. So if you're paginating through these results, the REST API itself is going to inform the client as to where you're at, what's next, and whatnot. So it reduces the amount of machinery on the client side and the implementers need in order to interact with these particular endpoints. And so, this affords a much simpler client implementation leveraging this API. A query follows along the same lines. So we're getting a value through the method here. The query string itself is a URL encoded general query. So this is the same syntax you're using with iQuest. Select this, that, and the other thing, et cetera, et cetera. We take a limit, we take a row offset, and then we take a query type. So you can either invoke a general query or a specific query. And the results of that looks quite similar also. So if we ask for the data objects or anything, it's going to have a listing that looks very similar to the listing. Or it's going to have a result that looks very similar to the listing. But the URLs down here are effectively also query operations. If you want to go to the last in the query or the previous, or where I'm at currently, or of course, what is the next page in this query. We also include the count down here and the total number of rows returned. Now, for interacting with data objects, we have a stream interface, which takes both a put or a get. These are implemented as individual endpoints, so they can be containerized individually, but they are fanned out through the reverse proxy Nginx based on method. So we can take a path, we can take an offset, into that particular data object, or limit the number of bytes read rather than just fetching that whole object. So if we're putting data, we can just put some raw data into a data object following this URL encoded path, or we can request, just simply changing the method to get request data from that particular data object. Put doesn't return anything, assuming it's successful, and get will come directly to, as the body of that request, depending on the client you're using. And finally, we have zone reports. So the zone report is going to give you literally as much information as we can about every server within your particular zone. And this comes back, right over as the body. So assuming that you're an administrator, you can hit the zone report endpoint. And if we pipe that through JQ, you'll see that we have a zone bundle here with all of the zones that are configured within this zone report. And that's going to be many pages of information, including base64 encoded configuration files and everything else that happens to be in iRODS. So if you imagine you're using this in order to inform an interface, you can hit the zone report and then basically get the view into the zone in order to be able to render all of the contents of that zone report for your users of your brand new zone management tool. And that is all I have. Questions?
So we have one incoming, I believe. What was the trickiest part of this so far? Was it the auth
I mean,
part?
Once I got over the technological hump of Pistache and trying to generate things with YAML and all that other stuff, and I just kind of pared it down to what I wanted, it was remarkably simple. So I built, say, an abstraction around the framework used for providing the REST endpoints and whatnot with Pistache. And so each of these are implemented as a iRODS specific implementation, which is exactly what I called it for each of the endpoints. And then I built like a macro system that can template out the Pistache parts, and became a lot easier. So I really just had to come up with a framework for building these things, and from there it was pretty straightforward, because it's largely just bolting REST on top of the underlying libraries, like the file system library for listing, or the query processor, or the query iterator for the query endpoint, and whatnot. And so we could do more work in order to make this more HTTP friendly, if you will. But I mean, I think it's still holding together.
Yeah. And then, so what's the question from Adil? What's the lifetime of the token? Isn't that part of the? That's always
the lifetime of the token is baked into that token itself, and should be part of the configuration for the auth endpoint.
Right.
So from there, but what we haven't implemented yet is if you're working with a token-based system like that, there is the, oh, my token is expired, let's renew or refresh my token, and some of those concepts have not been fully fleshed out. One is which is what I mean by being HTTP friendly.
Right. Yeah, I don't think we have a lot of the refresh stuff. It's basically one to one, and then go get a new one.
Yeah, that would effectively be it at the moment.
Right.
So we could there's standards around that, of course, that we can follow. But
another question from a Justin James. He asks, do you see this fully replacing the jargon-based REST interface? This is a loaded question.
That is a highly politically charged question, Justin. I don't know. No, I really don't. I mean, Mike has put an enormous amount of work in order to, build out the ecosystem all around Jargon and the mid-tier. I wanted something that was going to be, like I said, lightweight and very specific to the tasks at hand. So, we're building a very, light zone management tool on top of this. And there's some concepts like connection pooling under the covers and whatnot, but like I said, there's still a lot of work to make it much more standardized and HTTP friendly. I think I dodged that sufficiently.
Well, we'll see. Mike is typing something.
I was going to say, I bet Mike is typing furiously.
I was trying to promote him, but I don't see him anywhere in the chat list here. It says the jargon-based one is sort of deprecated. It's pretty long in the tooth. That's a Mike Conway-ism.
Well, that's news to me.
For what it's worth, I will be working on some new things as I can get time. Want to focus on services beyond, bread and butter stuff. So probably a mix of Java and Go-based stuff as appropriate. So
he just needed some new buzzwords to throw around.
He's got the tic-tac-toe board going. And then Ton asks, how is performance of a paginated query versus regular client lib interface?
A paginated query versus a regular client, what?
Client library interface approximately. I guess he's asking if this is any different than, going through a client library.
It is no different than going through iQuest.
Yeah, it's the same.
It uses all of the exact same facilities.
Right.
Yeah. And when we get the next generation general query interface in, that implementation, it actually supports cursors, and so it will paginate much more quickly because we'll be maintaining a little bit of state.
Yeah.
Something I hadn't mentioned and still needs exposed under configuration is that there is a connection pool underneath this that actually supports expiry, and so the connections will eventually just time out and refresh themselves. And so the goal here, when the new general query is available, is to provide a hint that'll allow the endpoint to reuse a connection. And so there'll be a little bit of information that can go back and forth between them that a client can show up with and say, hey, this is like my session ID, along with your JOT. and then it can pull that connection out, which means you'll be able to take advantage of things like cursoring. So it breaks the, atomicity of the REST philosophy, but will also go considerably faster than having to page past, 100,000 items you've already, asked for.
Right. It also means that if the database had changed, if the truth had changed in the meantime, you're not getting duplicate or skipped entries as you requery and then skip. Yeah. Let's see. What Laura's asking questions that, okay, I'm going to read the question from Laura Capps. It says, I have a question. What would be the level of effort for implementing parallel transfer engine, which goes to the REST API?
That would be exactly the same as the Python client implementation. So that stream interface gives you the ability to, offset read and write just like you would with the Python iRODS client.
And we are going to demonstrate that during a lightning talk this afternoon.
How long has she been sitting on that question? That's
I'm not sure. It's a very, very well worded question.
It's quite specific.
Mike and Ton, I gave you a microphone if you want to say anything else. But otherwise, we might be about done here. All right, 3, 2, 1.
All right.
Very good. Thank you, Jason.
All right. Thank you.